Imagine a planet so big it could hold all other planets. This planet is Jupiter, a true giant in our solar system. It is not like Earth with hard ground to stand on. Jupiter is a swirling ball of gas, very, very far from us. It shines brightly in our night sky, a big star-like dot. Many people have looked at it through telescopes for years. They see its beautiful colors and its mysterious storms. Jupiter is a king, ruling its part of space with its great size. It holds many secrets about how planets are born, and it continues to fascinate us with its majesty. Jupiter is named after the king of the Roman gods. This name fits it very well because it is the largest. It is so big you could fit 1,300 Earths inside it. Think about that, our whole world, many times over. This giant planet spins very fast, faster than any other. A day on Jupiter is only about 10 Earth hours long. Even though it is huge, it turns around so quickly. This fast spinning makes its clouds stretch into bands. These bands of color are one of Jupiter's famous features. We have much to learn about this incredible giant world. This giant planet is like a big brother in our solar system. It has a strong pull, a force called gravity. This gravity is so powerful it affects other objects nearby. It can pull comets and asteroids towards it, or away. Some scientists think Jupiter protects Earth by doing this. It might catch space rocks that could otherwise hit us. So this giant king might also be a quiet guardian for us. Its presence has shaped how our solar system looks today. Jupiter's story is a big part of our cosmic family story. It is a world of wonder waiting for us to explore. Studying Jupiter helps us understand more than just one planet. It teaches us about how solar systems form and change. Gas giants like Jupiter are common around other stars. So, learning about our Jupiter helps us understand those too. What is it made of? What are its storms like? How did it get so many moons? These are big questions. Scientists use powerful telescopes and brave spacecraft. They send these explorers to get a closer look at Jupiter. Each new picture, each piece of data tells us more. Jupiter is truly the king, a majestic and important world. Jupiter is incredibly big, the biggest planet orbiting our sun. If you could put all the other planets together in one ball, Jupiter would still be more than twice as massive. Its size is hard to imagine, truly on a grand scale. The diameter of Jupiter is about 11 times Earth's diameter. That means you could line up 11 Earths across its middle. This makes it a giant, a king in our solar system family. Its sheer volume means it has a lot of stuff in it. Most of this stuff is light gases like hydrogen and helium, but there is so much gas that it weighs a lot. This huge planet is not just wide but also very heavy. Its mass is 318 times the mass of our Earth. This immense mass gives Jupiter very strong gravity. Gravity is the force that pulls things towards each other. Jupiter's gravity is so strong it affects everything near it. It pulls on its many moons, keeping them in orbit. It even tugs on distant comets and asteroids passing by. This strong pull helped it gather so much gas long ago. When the solar system was young, Jupiter grew very quickly. It became the giant we see today, dominating its region. Think about Jupiter's size compared to our own planet Earth. Earth is our home, and it seems very big to us. We travel for many hours to go from one country to another. But if Earth were the size of a small grape, then what? Jupiter would be like a big, round basketball in comparison. This shows you the difference in their grand scales. It truly is a giant, a behemoth in our cosmic neighborhood. When you see it in the sky, it looks like a bright star, but it is so much bigger and more complex than a star point. Its grandness is something that fills us with awe. The sheer scale of Jupiter influences its entire being. Its massive core, if it has a solid one, is under pressure. This pressure is immense, unlike anything on Earth. The materials deep inside Jupiter behave in strange ways. Hydrogen gas can become like a liquid metal there. This is because of the weight of all the gas above. Jupiter's size is not just about being big for no reason. It dictates its weather, its magnetic field, its internal heat. It is a fundamental characteristic of this amazing planet. Understanding its scale helps us understand Jupiter itself. Jupiter is the fifth planet from our sun in the solar system. First comes Mercury, small and very close to the sun's heat. Then Venus, a hot and cloudy world similar in size to Earth. Third is our home, Earth, with its oceans and life. Fourth is Mars, the red planet, cold and dusty. Beyond Mars there is a big gap, the asteroid belt. And then after this belt of rocks comes mighty Jupiter. It is the first of the gas giants, the outer planets. These planets are much bigger and made mostly of gas. Jupiter marks the beginning of this outer realm. Being the fifth planet means Jupiter is quite far from the Sun. It is about 778 million kilometers or 484 million miles away. This is more than 5 times farther from the Sun than Earth is. Because it is so far, it takes a long time to orbit the Sun. 1 year on Jupiter, its journey around the Sun, is very long. It lasts for almost 12 Earth years, a dozen of our years. So if you were 12 years old on Earth, you'd be just 1 on Jupiter. This long journey defines its seasons, if it has any like ours, but its distance means it receives much less sunlight than Earth. This affects its temperature and the energy driving its weather. Jupiter's position in the solar system is very important. It sits between the rocky inner planets and the icy outer ones. Its huge gravity has a big influence on this whole region. Think of it like a giant vacuum cleaner or a bouncer. It has likely cleared out many smaller objects from its path. It might have prevented a planet from forming in the asteroid belt. The asteroid belt is full of small, rocky bodies, not a planet. Jupiter's strong pull stirred up these rocks too much, so they could not come together to make a new world. Its place helps shape the structure of our solar system. The distance from the Sun also means Jupiter is very cold. At the top of its clouds, the temperature is frigid. It is about minus 145 degrees Celsius, or minus 234 Fahrenheit. This is much colder than any place on Earth, naturally. However, deep inside Jupiter, it is incredibly hot. The planet actually makes more heat inside than it gets from the Sun. This internal heat comes from its slow shrinking and movement. So, its place far from the Sun doesn't mean it's entirely frozen. It has its own engine deep within its gaseous layers. Jupiter is a dynamic world, despite its chilly outer clouds. Jupiter is not like Earth, which has a solid, rocky surface. You cannot stand on Jupiter, there is no ground to find. Instead, it is known as a gas giant planet. This means it is made mostly of gases, light elements. The 2 main gases are hydrogen and helium, the simplest ones. These are the same gases that make up our Sun. In fact, Jupiter's mix of gases is very similar to the Sun's. It is like a star that never got big enough to light up. It has a lot of hydrogen, about 90% of its atmosphere. The rest is mostly helium, with tiny bits of other things. Deep inside Jupiter, the pressure is extremely high. Imagine all that gas pressing down from above. This immense pressure changes the way hydrogen behaves. The hydrogen gas gets squeezed so much it becomes a liquid. So, below the clouds there might be a huge ocean of liquid hydrogen. Deeper still, the pressure gets even more intense, truly crushing. Here, the liquid hydrogen might change again. It can become something called liquid metallic hydrogen. This strange stuff can conduct electricity like a metal. This metallic hydrogen layer is thought to create Jupiter's strong magnetic field. Scientists are still learning about Jupiter's very center. Does it have a solid core, a hard ball in the middle? It is hard to know for sure, hidden beneath all that gas. Some theories suggest it might have a small, dense core. This core could be made of rock and ice, heavier materials. These materials would have sunk to the center long ago. But this core would be very different from Earth's core. It would be under unimaginable heat and pressure. Other models suggest the core might be fuzzy or spread out, or perhaps it is dissolved into the metallic hydrogen above. The small amounts of other chemicals give Jupiter its colors. We see bands of white, yellow, brown and red in its clouds. These colors come from traces of compounds mixing with hydrogen and helium, things like ammonia, methane, water, and sulfur compounds. When sunlight hits these chemicals, or when they react together, they form the beautiful and complex patterns we observe. The swirling storms and fast winds mix these colors up. This creates the dynamic, ever-changing face of Jupiter. It is a giant chemical factory, a world of gas and color. Its composition is key to understanding its stormy nature. Section 5. Jupiter's wild weather, a sky full of storms. Jupiter's atmosphere is a place of wild and powerful weather. It's not calm and peaceful like a clear blue sky on Earth. Instead, it's filled with giant storms and incredibly fast winds. These winds blow in opposite directions in different bands. The light-colored bands are called zones, where gas is rising. The dark-colored bands are called belts, where gas is sinking. This constant up and down motion creates strong jet streams. Winds on Jupiter can blow much faster than the strongest hurricanes. They can reach speeds of over 600 kilometers per hour. That's more than 370 miles per hour, truly extreme. The most famous feature in Jupiter's sky is the Great Red Spot. This is a giant storm, bigger than the entire planet Earth. It has been raging for hundreds of years, a persistent tempest. We've been watching it since telescopes became good enough. It's like a hurricane, but much, much larger and longer lasting. The Great Red Spot rotates counterclockwise, a huge swirl. Its color can change, sometimes more red, sometimes paler. Scientists are still studying what gives it its reddish hue. It might be complex chemicals reacting with sunlight. This storm is a symbol of Jupiter's powerful, chaotic atmosphere. Jupiter also has many other storms, not just the Great Red Spot. There are smaller white ovals and brown barges, other types of storms. Some of these can last for many years, others come and go. Lightning flashes are also common in Jupiter's turbulent clouds. These are not small sparks, they can be huge, powerful bolts, much stronger than any lightning we see on our own planet. Spacecraft missions like Galileo and Juno have seen these flashes. They tell us about the energy and activity within the clouds. Jupiter's sky is an electric, stormy, and very active place. It's a natural laboratory for studying extreme weather. What drives all this wild weather on the giant planet? One major factor is the heat coming from inside Jupiter. As we said, Jupiter produces its own internal heat. This heat rises up and helps to stir the atmosphere. Another factor is Jupiter's very fast rotation, its quick spin. A day on Jupiter is less than 10 hours long. This rapid spinning twists the weather patterns into bands and swirls. Sunlight also plays a role, though it's weaker there. All these things combine to create the dynamic, stormy world. Jupiter's weather is a constant show of nature's power. Section 6: Jupiter's many moons. A mini solar system within ours. Jupiter is not alone as it journeys through space. It is accompanied by a large family of moons, many of them. As of today, scientists have discovered over 90 moons orbiting Jupiter. This number keeps growing as our telescopes get better. Some of these moons are very small, just captured asteroids. They are like little rocks, irregular in shape, tumbling around. But Jupiter also has some very large and fascinating moons. These are worlds in their own right, with unique features. This whole system of Jupiter and its moons is like a mini solar system. It shows us how planets and moons can form together. The 4 largest moons of Jupiter are called the Galilean moons. They were first seen by the astronomer Galileo Galilei in 1610. He used one of the first telescopes to look at the sky. These 4 moons are Io, Europa, Ganymede, and Callisto. They are big enough that you can see them with good binoculars. Galileo's discovery was very important. It showed not everything orbits Earth. This helped change our understanding of the universe's structure. Each of these 4 moons is a special and different world. They offer clues about where we might find interesting conditions. Conditions perhaps that could even support some form of life. Io is the closest of the Galilean moons to Jupiter. It is the most volcanically active world in our solar system. Its surface is constantly changing due to hundreds of volcanoes. These volcanoes erupt sulfur and sulfur dioxide, making it colorful. Europa is a bit farther out and it is covered in ice. Scientists think there might be a huge ocean of salty water under this ice. This hidden ocean could be a place where life might exist. Ganymede is the largest moon in the entire solar system. It is even bigger than the planet Mercury, a true giant moon. It has its own magnetic field, which is very unusual for a moon. Callisto is the outermost of the 4 Galilean moons. Its surface is very old and heavily cratered from impacts. It shows us what the early solar system might have been like. Beyond these 4 big moons, there are many smaller ones. These other moons have diverse origins and compositions. Some orbit in the same direction Jupiter spins, called prograde. Others orbit in the opposite direction, called retrograde. These retrograde moons were likely captured by Jupiter's gravity. Studying all these moons helps us understand planet formation and the conditions needed for worlds to become habitable. Section 7: Jupiter's faint adornments, the planet's hidden rings. Many people know that Saturn has beautiful bright rings, but did you know that Jupiter also has rings? They are there. Jupiter's rings are much fainter and harder to see than Saturn's. They are made of tiny particles of dust, not big icy chunks. These dust particles are very dark, so they don't reflect much sunlight. That is why they were not discovered until 1979. The Voyager 1 spacecraft saw them when it flew past Jupiter. It was a surprise discovery for many scientists at the time. These rings are a subtle, almost hidden feature of the giant. They add another layer of complexity to this amazing planet. Jupiter's ring system is made up of several main parts. There is a main ring, which is relatively thin but bright. Inside this main ring there is a thicker, fainter ring called the halo. The halo is like a donut shape of dust particles. Outside the main ring there are two very wide and faint rings. These are called the Gossamer rings because they are so sheer. They are named after two of Jupiter's small moons, Amalthea and Thebe. It is thought that dust from these moons helps create these rings. So, the rings are closely connected to Jupiter's moons. They are not as grand as Saturn's, but still quite interesting. The dust particles that make up Jupiter's rings don't last forever. They are constantly being ground down or pulled into Jupiter. So, for the rings to still be there, they must be refilled. Scientists think this happens when tiny meteoroids hit Jupiter's small inner moons. These impacts kick up dust from the surfaces of these moons. Moons like Adrastea, Metis, Amalthea, and Thebe are key sources. This dust then goes into orbit around Jupiter, forming the rings. So, the rings are like a dusty cloud constantly being supplied. This is different from Saturn's rings, which are older and icier. Jupiter's rings are dynamic and constantly changing structures. Studying Jupiter's rings helps us understand ring systems in general. Not all rings around planets are the same or formed the same way. The rings of Jupiter tell us about the environment close to the planet. They show how dust behaves under Jupiter's strong gravity and magnetic field. Spacecraft like Galileo and Juno have given us closer looks. They have helped us measure the size and shape of the rings, and they have helped us understand where the dust comes from. Even though they are faint, Jupiter's rings are an important part. They are part of the whole Jupiter system with its planet moons and storms, a delicate feature around a very powerful, massive world. Section 8, Exploring the Giant, Our Robotic Messengers to Jupiter. Humans have not yet traveled to Jupiter, it is too far and harsh. But we have sent many robotic explorers, brave spacecraft. These missions have taught us almost everything we know up close. The first spacecraft to visit Jupiter were Pioneer 10 and 11. They flew by in the early 1970s, taking the first pictures. They showed us that Jupiter was even more amazing than we thought. These early missions paved the way for more advanced explorers. They tested if spacecraft could survive the long journey, and they measured the strong radiation around the giant planet. Their data was crucial for planning future explorations. Later, the Voyager 1 and Voyager 2 spacecraft flew past Jupiter. This was in 1979, and they gave us incredible new views. They discovered Jupiter's faint rings and active volcanoes on Io. They saw the complexity of the Great Red Spot and other storms. The Voyager missions were like a grand tour of the outer solar system. Jupiter was a key stop on their long journey to other giants. The images and data they sent back were revolutionary. They changed our understanding of Jupiter and its moons forever. These probes continued to travel, now far beyond our planets. But their Jupiter findings remain a treasure for science. The Galileo spacecraft was the first to orbit Jupiter. It arrived in 1995 and studied the planet for almost 8 years. Galileo dropped a probe into Jupiter's atmosphere, a daring feat. This probe sent back data about the clouds and winds. It measured temperature, pressure, and what the air was made of. The orbiter itself studied Jupiter's moons in great detail. It gave us strong evidence for an ocean under Europa's ice. Galileo's mission was full of challenges but hugely successful. It provided a deep, long-term look at the Jupiter system. Its legacy is a wealth of information we still study today. More recently, the Juno spacecraft has been orbiting Jupiter. It arrived in 2016 and is still sending back amazing data. Juno's mission is to understand Jupiter's origin and evolution. It flies very close to the planet, over its poles. This path helps it study Jupiter's powerful magnetic field and its gravity to learn about what is deep inside. Juno has sent back stunning images of Jupiter's swirling polar clouds. These views are unlike anything we had seen before. Each new mission builds on the last, revealing more secrets. Jupiter continues to be a prime target for space exploration. Section 9. Why Jupiter Amazes Us, a never-ending cosmic wonder. Jupiter fascinates scientists and space lovers for many reasons. Its sheer size is breathtaking, a true giant in our cosmic home. It is a king among planets, dominating its part of space. Its colorful, swirling clouds are like a giant work of art. The Great Red Spot, a storm bigger than Earth, rages on. This shows us the immense power of nature on other worlds. Jupiter is so different from our own planet, Earth. It challenges our ideas of what a planet can be. It is a world made of gas, with no solid surface to stand on. This makes us wonder about the diversity of planets everywhere. The family of moons orbiting Jupiter is another source of wonder. From volcanic Io to icy Europa with its hidden ocean, these moons are worlds in themselves, each with unique stories. Europa especially captures our imagination with its potential. Could there be life in its dark underwater realm? This question drives much of our interest in exploring Jupiter. Ganymede, bigger than Mercury, even has its own magnetic field. These discoveries show that moons can be as complex as planets. Jupiter's system is a natural laboratory for studying worlds. It helps us understand how planetary systems form and evolve. Jupiter also plays an important role in our solar system's story. Its strong gravity has shaped the paths of asteroids and comets. It might have protected Earth from many impacts long ago. By studying Jupiter, we learn about our own planet's history. We learn about the conditions that allowed life to arise here. Jupiter is like a time capsule holding clues from the early solar system. Its composition is similar to the Sun and the gas cloud that formed everything. So, understanding Jupiter helps us piece together our cosmic origins. It is a key player in the grand drama of our solar system. Its influence is felt far beyond its own cloudy atmosphere. The quest to understand Jupiter is a never-ending journey. Each new discovery brings more questions, more to explore. Future missions are being planned to visit Jupiter and its moons. They will carry even more advanced instruments to probe its secrets. We want to know more about its deep interior and its magnetic field. We dream of exploring Europa's ocean, searching for signs of life. Jupiter is a beacon of curiosity in the night sky. It reminds us of the vastness and wonder of the universe. It inspires us to keep looking up, to keep exploring. The King of Planets will continue to amaze us for generations.